This video goes with Unit 6, which is Chemical Equations and Reactions. The essential questions are: what is a double replacement reaction, what is a combustion reaction, and how can you tell the difference? So, double replacement, these usually occur in a water solution. The general formula is if you have A and B together and C and D together, then they're going to trade partners. Okay, so they still need to have a positive and negative. So if A is positive, it's now, and C is positive, on the right side it's going to go with D, and C would go with B. Okay, here's another way to visualize it with dance partners. Swap out dance partners, and that's a double replacement reaction. Okay, a precipitation reaction is when you all of a sudden have when you mix two liquids and all of a sudden some solid falls to the bottom. That's called a precipitate. So this is an example of one. We have potassium iodide combining with lead nitrate, and it makes that yellow precipitate because it's not soluble in water. It won't dissolve in water. So we're going to do a couple practice and show you how you identify that it's a double replacement. The first one is mix aqueous solutions of potassium chromate and barium nitrate to make barium chromate and potassium nitrate. So we know how to write these equations. So I have potassium chromate. I've already done my crisscross, and it says aqueous, and barium nitrate, and it says aqueous. I have barium chromate, and again I'm checking on all these that my crisscross is correct, and potassium nitrate, okay, which is aqueous. Okay, we also need to balance. I have two K's on the left, and so I need two on the right. And I also need two KNO3s. So when I look at that, I can see that the K on the left side was with chromate, CrO4, and now on the right side it's with NO3. And I can see on the left, barium was with NO3, and then on the right side it's with CrO4. So that tells me it's a double replacement reaction. Let's look at another one. Mix solutions of lithium hydroxide and copper 2 chloride to make copper 2 hydroxide and lithium chloride. So lithium hydroxide is LiOH. Copper 2, that's aqueous because it's a solution. Copper 2 chloride, I'm going to do my crisscross, and that's also aqueous. And that's going to make copper 2 hydroxide, and again I do my crisscross, and lithium chloride. Okay, copper 2 hydroxide is not soluble. And you can look that up on your solubility chart, and we'll talk more about that in later units. And then lithium chloride is aqueous as well. If I check my balancing, I need two OHs. I have two on the right, so I need two on the left, and that gives me two lithium. So I need two on the right, and then my chlorines work out, and everything's good. So again, if I look at this equation, lithium starts out with hydroxide and ends up with chlorine. Copper starts out with chlorine and ends up with hydroxide, so they made a switch. So I can identify this as a double replacement reaction. Okay, so this is kind of a visual. We've already talked about synthesis and decomposition. Synthesis coming together, decomposition breaking apart. Single replacement is the first one there, and we've talked about that as well. And then double replacement, they switch sides. Now, finally, we're going to look at combustion, and the general formula for this is you have some combination of C's, H's, and O's. You add O2 to it because that's what happens when something is on fire. And that ends up making carbon dioxide and water every time. So the hard thing about combustion is really just the balancing. So for instance, propane, C3H8, I have some combination of C's, H's, and maybe O's. I add oxygen, because that's what combustion is. I get CO2 and H2O. Now I have to balance. So I have 3 C's on the left, I need 3 on the right. I have 8 H's on the left, so I need 8 on the right. And then I count up all my oxygens on the right, and I have 10. So I need 5 sets of 2, which is 10 on the left. Okay, so here's another visual of that, showing the balancing and how that worked. Okay, another one, ethanol. You don't have to know which these are, but you do need to be able to recognize if you see this stem, it's going to be some kind of C's, H's, and O's, and adding O2, that's going to be a combustion reaction. Okay, again, I'm always going to get CO2 and water. I need to balance, so I put a 2 here for my carbons. I have 6 H's on the left, so I need 6 on the right, and then I check out my oxygen. I have 7. There's 1 in that ethanol, so I just need to put a 3 there to get the other 6. So let's practice. If we look at the first one, I see C's and H's mixing with oxygen. That's a combustion. Okay, on the next one, I see 2 compounds, NaCl, AgNO3, and they're switching places, AgCl and NaNO3, so that's going to be a double replacement. Okay, on number 3, I see again 2 compounds, H with Cl, and then later it's with OH, and K would start out with OH and then became KCl, so again, that's double replacement. If we look at number 4, we were taking C's, H, and O's and adding oxygen, so we know that's combustion. And on number 5, I have one element by itself and it's kicking another one out, so that's going to just be a little review for us. That was single replacement.